Okay, so we're going to look some trigonometry. We're going to practice the sine rule, the trig ratios, and Pythagoras theorem. In it, we're going to look at both right-angled triangles and non-right-angled triangles. So on the left-hand side, we've been given a problem where you have two triangles, ABC and CBD. In it, we have an angle of 63 degrees, an angle of 46 degrees in the other triangle, and one of them is a right-angled triangle. When you see a problem like this, it is really important that you put in as much information as you possibly can into both triangles. When it comes to solving these, the more information you pop into this, the easier it will be to solve. Okay, there's a couple of things we need to remember when we talk about triangles. In every triangle, there are 180 degrees. So when you add up the three angles in a triangle, you should get 180 degrees. From this information, we should be able to solve every single angle in the triangle. Okay, and I'm going to pop in a few of them and explain how these measurements have been arrived at. Okay, so just with your calculator, I'm going to be taking 180 away from the 63 and the 90. 63 and 90 away from 180. So 180 minus 63 degrees minus 90 degrees. That'll get me 27 degrees up on top here. Is that all right? Just on this triangle then, we have 46 degrees. We also have a straight line going on, and in every straight line there's 180 degrees also. So 180 minus 63 gets me 117 degrees inside here. And now that we know that angle, we'll actually be also able to calculate the angle on top here by doing 180 minus 117 minus 46, and that gives us 17 degrees up on top. We might not need all of these angles, but it's important that you put in as much information as you can, so it helps us solve which sides and angles that we have and which ones we need to solve afterwards. Just looking at the question, there is one other measurement that is missing from this question, and it's the distance from A to C is 100 meters. Okay. In this question, what we're asked to do, there's three parts to it. We're asked to find a distance from C to B. That's the first thing we're asked, and I'm going to put in, if I don't know something in maths, I call it X. Okay, so the distance from C to B, I need to calculate it to the nearest meter. Let's just look at the right-angled triangle for a moment. Okay, in order to solve a right-angled triangle, there are kind of two main formulas that we can look at. It's Pythagoras theorem or trig ratios. And in order to do that, we need at least two pieces of information in order to solve it. So in the right-angled triangle, I don't have a side that I know, but I do have an angle. So I don't have two pieces of information, a side and an angle, in order to calculate a third side. So I cannot use the right-hand side triangle. I'm then going to have to focus on the left-hand side triangle. I'm just going to redraw it out to make it a little bit easier for us to see. I'm going to draw it slightly bigger as well. Okay, in it, I have 117 degrees. I have 46 degrees. I have 100 meters. That's A, C, and B. I also have 17 degrees up there. And I'm looking for this side, X. Okay. When it comes to non-right-angled triangles, there's a good system to use that will help us solve if it's going to be sine rule, and later if it's going to be cosine rule that we'll have to use. So I'm going to write down angle A, angle B, angle C, side A, side B, side C. And if I have these, I can start inputting measurements. Okay, so angle A is 46. Side A is X. Angle B is 17. Side B is 100. Angle C is 117. Side C is I don't know. Okay, I am asked to calculate the distance from B to C, which is side X. So, in order to use the sine rule, there has to be one full piece of information we know and one unknown piece of information. The best thing to do is write out your sine rule, and we'll sub into it and solve. Okay, so as you've recalled, there are 4 steps in solving any question. 1, you label your diagram. 2, you write out your formula. 3, you sub into that formula. And then 4, you solve it. We have labelled our diagram. We're now going to write down the formula. We know we now need to use the sine rule, so I'm going to write out its formula. So that's A over sine A equals B over sine B. And I'm now going to sub into that formula. Small a is x. The angle A is 46. Side B is 100. And the angle for B is 17. When you have a fraction on one side and the fraction of the other side of a equal sign, you have to cross multiply to solve it. In cross multiplying, you're going to multiply the x by the sine of 17 and the 100 by the sine of 46. And I'm just going to move my image a little bit further out. Okay, move it to the right hand side. Okay, so we have x sine 17 is equal to 100 sine 46. The whole purpose of this question is to get the value of x. So I want x and its own, these two things are multiplied. The opposite to multiply is divide. So my answer will be 100 sine 46 over the sine of 17. And I can pop this all into the calculator. Grab your calculator and start writing in exactly as it is. So 100 sine 46 over sine 17. Close off your bracket and press equals. Is 246.03 meters. In the question, we were asked to correct it to the nearest meter, which will be 246. Okay, meters. Make sure you put the unit, and that is part 1 of the question done. Okay, now that we have part 1 done, put in the information as you have found it. So I know x now is 246. Go back up to your original diagram, and we know this distance is 246 meters. The next thing we need to do is find the distance from D to B. Let's have a look where that is. D to B is the vertical height. Okay, so that's our new value for x. Okay, so we're going to be dealing with a right angled triangle this time. It might be a good idea to label our diagram, sub in and solve. We are going to redraw out our diagram, so I'm just going to do it here on the right hand side. As best we can. Okay, I'm looking for this. I know the top one is 27, we had that earlier on. I know this is 63 degrees. I know we've just found this to be 246. This is C, B, and D. Okay, so I'm looking for the distance from B to D. It is a right angle triangle. 2 formulas should be popping out in your head. One of them is Pythagoras Theorem and the other one are the trig ratios. Because there's an angle in this question, we are more than likely going to be using the trig ratios. Okay, so I'm going to label my diagram. I'm going to sub into my diagram and solve. This is my angle, so that is known as my opposite. Opposite to right angle is known as the hypotenuse. Okay, so I've labelled my diagram. That's the first step that we always look at, labelling the diagram. We're then going to write out the formula, sub in and solve. So, labelled my diagram, I'm going to write down my formulas for trigonometry are sine, cos, and tan of the angle, which is 63. Some people have rhymes to help them remember this. Some people use Sockatua. Some people use silly old Harry. Caught a herring trawling off America. We have the opposite, which is O, and the hypotenuse, which is H. We look along here and we can see that O and H, I have to use a sine of 63. Now that I've figured out it's a sine of 63, I'm going to sub in and then solve it. So we'll write out sine 63. The opposite is x. The hypotenuse is 246. Like everything, if you have a fraction on one side, make the other side of the equal sign a fraction, and you're going to cross multiply. For anyone that's wondering, to make any number a fraction, you can put it all over the number 1, and we're going to cross multiply. 1 multiplied by x is x. 246 by the sine of 63 is 246 sine 63. We can type this into the calculator exactly as it is. So you'll type in 246 sine 63, close your bracket off and press equals, and we get 219.187 meters. In the question, we are asked to correct the nearest meter, and this is part 2 of the question. And the nearest meter will be 219 meters. Okay. So we've used sine rule and we've used trig ratios. What is the last part of the question? The last part of the question, I'm just going to go back over it, is find the distance from C to D. C to D is this distance here. I'm just going to pop in what we've got. So this x, now we've calculated it to be 219 meters. And we're looking for the last side, C to D. So I'm going to pop that into this diagram here. And I might redraw it out for ourselves. So part 3. I'm going to redraw out my diagram just to make it clear for myself that I know what I'm looking for and what I have. Because sometimes when you have so much information in the one diagram, it can get quite confusing. Okay, so I have 63 degrees, 27 degrees. I have my 90 degrees. I'm just after finding this to be 219 meters. I had this to be 246 meters. And I'm asked to find a distance from C to D, which is this one. When you are finding something in maths, you generally call it x. So we have a triangle. We have 2 sides and we're looking for the third side of it. We do have angles. So we could use any of these trig ratios. But what we're going to do instead is, because we have 2 sides of a triangle and we're looking for the third side, we're going to use Pythagoras' theorem. So there's 4 steps. We're going to label our diagram first. So this is the hypotenuse, the opposite, and the adjacent. Okay. Now your formula for Pythagoras' theorem is the hypotenuse squared is equal to the opposite squared plus the adjacent squared. However, in your log tables, it's written as c squared is equal to a squared plus b squared. This formula and this formula are the exact same thing. It just depends on what you label your diagram. So if you're used to the hypotenuse, it's the hypotenuse squared is equal to the opposite squared plus the adjacent squared. But if you go to your log tables, it's c squared is equal to a squared plus b squared. C is the hypotenuse. And after that, you're just subbing in and solving like you've always done. C is 246. I need to square it. A is 219 squared. And b is x to be squared. Let's start squaring the numbers. 246 to be squared is 60,516. 219 to be squared is 47,961 plus x squared. Basically, to solve this, we want letters on one side and numbers on the other side. It doesn't matter if you've letters left or numbers to the right, but you want all the numbers together. So I'm going to move the 47,961 across. And because I'm moving it, it becomes a minus. And that gets me x squared on its own. So I'm going to minus those two. 60,516 minus 47,961. And I get 12,555. In order to get rid of the square, we're going to do the opposite, which means getting the square root. And when we do that, we're essentially getting 112.04 meters. We've always got it to the nearest number, nearest meter, so we're just going to leave this as 112 meters. Okay, so there we have it. We have looked at using trigonometry. So our initial question is here to the left hand side, and we used the sine rule, the trig ratios, and Pythagoras' theorem in order to solve. Okay, so best luck. Hopefully that works for you. And as I said, you can always look back over this video if you've missed anything or I went too fast. Okay, so the first one was our sine rule. The next one was our trig ratios. And then finally, we finished off with Pythagoras' theorem. Okay.